Hello students. So today we will study drift velocity. Okay. Basically this concept comes under the subject electromagnetic theory, and the chapter name you can say is current electricity. In the chapter we study drift velocity. Drift velocity is related with the conductor because we know that in conductor there are always like n number of free electrons, and they can contribute in the conduction. But until or unless we do not apply any external electric field, they will not contribute in any like we can say they will not give any aggregate velocity, because they will be successively colliding with heavy ions, or we can say whatever ions will be there, because we know that the conductor is made with some atoms, and those atoms will be basically if we talk about copper, then copper has how many free electrons? Two electrons. And along that two electrons, the copper will have some ion. Okay. So uh, so if we assume a conductor wire, then what will happen? There will be a lot of electrons, and those free electrons will be colliding with heavy ions, and uh, after the collision, they will have some random direction, and they will move here and there in the conductor. Okay, so because of that, they will not get any, we can say the aggregate velocity, or we can say their average velocity will be zero, because they will make the path like, for example, if electron is starting from point A and it wants to go to point B, so it will not be a straight line path, because we know that while reaching A to B, it will collide with some ions like that, and it may make any sort of pattern, and finally it can reach to the point B. So this kind of pattern we see in the, we can say, random motion of the electrons, freely electrons, in case of conductor. Okay, so now how to find out the drift velocity? So drift velocity concept comes under when we apply an external electric field uh, to the conductor, or we can say external electric field in the sense when we apply any external voltage, or we can say the conductor is taken into the external circuit. Then what will happen? We will apply some voltage, and we know that voltage is going to give the electric field. Okay. So now in the initial condition, let me write initially. Initially, the average velocity of electrons. Okay, so the average velocity of electrons is written as V average, and that will be written as sigma over Vi upon capital N. Okay, where Vi is the velocity of ith particle, or we can say velocity of the ith electron, and N is the total number of electrons. Okay, let me write here. N is the here Vi is equals to velocity of ith electron, and N is total number of electrons. So this will be the average velocity. And until we are not applying any external electric field, their average velocity will be zero. So basically here we get this V average equals to Vi upon N equals to zero. The reason is very simple, because they will be moving in the random directions, and collectively when we add them, their total sum will be zero. Because for example, if an electron is moving in the left direction, after collision it may move in the backward direction. So its aggregate velocity, or we can say the aggregate velocity, or we can say the sum of the all the velocities, they will be going to zero. So that's why. So the initial average velocity is zero. Okay, and we should write here that when external electric field is not applied. Now we'll see for the second case when the external electric field is applied. Okay. So now we'll come to the point when external electric field is applied. Okay. For example, we apply some external electric field. Then what will happen? First of all, we know that when we apply an external electric field to any charged particle, there will be a force. And what kind of force it will be? It will be basically Coulombic force. Because here the force will be the force on electron. It will be F equals to minus E times electric field. Okay, F vector minus E times capital E vector, where capital E vector is the electric field and minus E is the charge of the electron. Okay, so here, let me write here, it is charge of an electron and E vector is external electric field. So here the force will be acting. This one F vector equals to minus E dot E vector. And now, according to the Newton's second law, we can write as per Newton's second law. What we can write? F vector will be nothing but ma vector, where m is the mass of electron and a vector will be the acceleration of electron. So equating these two equations, what we will get? We will get ma vector equals to minus e into e vector. So finally here, from here, we will get acceleration equals to minus e by m into e vector. So this will be the acceleration of the moving electrons. And how the scenario will change? Now we know that some force is acting. So basically it will give some push or pull towards any particular direction. Okay. So now the push and pull will be according to the charge particle, the type of the charge particle. Here we are talking about the electrons. So electron will be experiencing a force in the opposite direction of the electric field which we have applied. Okay. So for example, the electric field, for example, let's draw it. The electric field is in the right direction, like this. So if the electric field is in the right direction, then the force will be in the left direction. So here, this will be the direction of force, because we know that the minus, we can say electron is a negative charge particle. So that's why it will move in the opposite direction. Now, let us say the electrons were earlier also electrons were colliding with we can say the positive ions, but now the case is different. Now what they are doing, like for example, if after the first process, the initial after the first process, the initial velocity of some electron is, for example, mm, it is ui. Okay, initial velocity is ui. Let me write initial velocity. Okay. Now it is getting acceleration also from the electric field. And now let us say it is taking some time ti to collide with, or we can say to have the next collision. Okay, so it is taking time ti to collide with, to have the next collision. And now what, now the we can say the velocity after time ti, the velocity of that electron after time ti, it will be the velocity, the velocity the velocity of an electron after time ti. After time ti, what will be the velocity? Okay, so we should write here using Newton's first equation of motion. Equation of motion. So it will be capital VI equals to mole ui plus a into the velocity. We should write the vector form. So it will be a vector or ti. This will be the equation of velocity after time ti of an electron. Okay. Now we know that drift velocity is nothing but it is the average velocity of average velocity of electrons after applying the external electric field. So we have to take the average both of the sides, Vi and Ui plus A dot Ti also. Okay. Why we should take the average? Because again, what we are going to do, we have to take the average velocity because still the collisions are there. All the particles are not moving in the same direction. All the electrons are not moving in the same direction. They are still having the collisions. Okay, but at the end they will have some particular velocity in a particular direction. Particular velocity in the sense some average velocity in the particular direction they will have. Okay, so and the one thing more, the time ti is also going to change. Okay, so we have to take average of that also because the time will be like, the for example, for the first collision it will have some less time, and for the next collision it may have some more time also. The particle may take more time also. So for all of, uh, we can say, so deal with all these conditions we have to take the average. And here we will take the average time between two successive collisions. So here now we should take the average, taking average both the sides. So when we take average both the sides, what we will get, because we know that uh, average that we are taking is with respect to I, and here I is going to change from 1 to n. That we will write vector plus, because we know that here acceleration is constant, so we are going to take okay, let's say for this time we are taking it inside. But although the acceleration is constant that we know, and the changing thing is the time, the time between two successive collisions. Okay, so uh, here I is from 1 to 3 and it is going up to capital N. Now we know that the average velocity is named as drift velocity. So we should write here it is Vd because drift velocity. Now, as we know that the initial velocity when the electric field was not applied, we know that the average of that is already we have derived here. What it is? It is 0. So in place of this one, we have to write 0. And plus the acceleration a vector is, it is minus e upon m e vector. So we have to write minus e of m into e vector. And what is the average of ti? It will be tau. And what is the tau named as? It is the time relaxation time. Okay. So here tau is nothing but relaxation time. So tau is relaxation time here. So now the equation for equation for drift velocity becomes as Vd equals to minus E E vector upon M into tau. So this is the, we can say, uh, equation for drift velocity. Okay, now we'll see one important thing here, that one second. Okay, it is nothing but drift velocity. Okay, it is called as drift velocity. Now you can see that drift velocity is not depending on time. Okay, although we know that the particles are getting accelerated, but still the drift velocity is not depending on time, because here the tau is not going to change. Now the tau is nothing but it is the relaxation time. Okay, so here the drift velocity is not depending on the time. Okay, time, the word time I'm using here, that is the time taken between two successive collisions. Okay, so we should write also this point because it is important. One second, let me write. It does not depend on time. Although it depends on time, but that time is different. That is time constant, or we can say relaxation time. That will be constant. So this will be the drift velocity of electrons in conductors. If you have any doubt, then you can ask in the comment section. I'll try to resolve your doubts. Thank you.